compared to this problem right here, what's the first step? Minus the 8 to both sides. What our goal is here is to isolate the log term so that we can end up solving for x. So we begin by subtracting 8. Oops, really big eraser. By the way, what is this in front of the n? Like literally, what is it? An L. So yes, on yesterday's quiz, some people put 1, some people put I, and I think that must be because you weren't doing your work or listening to the video from last week, because it's definitely an L. Okay, what next? Divide by -7. So now I have natural log of 6x equals -1. How come I can't divide by 6 right here? Because of the ln, the log, right? That x has a log being done to it. So we have to undo the log by doing the inverse. What's the inverse of log? Exponential. And what skill do we have to go from log to exponential? Lasso. We start with the base, but I don't see a base. What is that? It's e, right? Okay, so I'll talk about why it's not 10 in just a second. Remember, ln is another way of writing log base e. If the base were to have been a 10, what you would have seen instead is the letters log instead of ln. It would have looked like this. This would have meant a 10 right there. But ln means base e. So once you remember that, you can lasso. You start with the base, you go around the opposite side and back to where you began. So it's e to the -1 equals 6x. And what's the last thing you have to do to get x by itself? Divide by 6. This is called exact form. We would use the calculators if I wanted approximate form, which I don't, which would give you the decimal. But there's one random bonus thing we have to do here that's not actually part of this unit. What don't we like about the form in this answer? As mathematicians, we don't like what? Negative exponents. So technically, even though our math was all good, we need to change that exponent to positive. That means you flip the base, which is e, and change the -1 to a positive 1. 6, you do not have to change at all. It does not have a negative exponent. So the e just comes down here, and we make the exponent positive. So the final form for our answer really should be 1 over 6e, where e has a positive 1. And the reason why it's 1 on top is because I flipped that base e. Instead of e over 1, it's now 1 over e. Questions about that problem at all? Okay. Let me get you your notes for today. What is the title of your lesson for today? Compressing logarithms. What does it mean to compress something? Make it smaller, right? So our goal for the day is to compress logarithms. For example, we will write the following as a single expression. Log, or natural log x minus 3 plus 2 natural log of 3x. The way this is written right here, how many logs do you see? 2. To compress it means to use some property where you can rewrite it so it means the same thing, but it only has 1 log that's going on. And we have 3 properties we're going to talk about today that will help us do that. But let me tell you why we even care about that, first of all. In the warm-up, solving this equation, how many logs do you see? 1, and that was great because once we got down to 1 log, or once we got the log isolated, rather, we would do the lasso and solve. But if there was more than 1 log, it would be hard to figure out where you're going to do your lasso. Like, if you had this, for example, it wouldn't make sense to do the lasso. What would it even mean? If you started with 1 base and came around, well, what would happen with the other log? How would you solve for x? So our goal today is to figure out how to compress these into 1 log, so then we could do lasso. And we'll be solving equations in a couple of days. Today and tomorrow, we're just practicing these properties for rewriting. So there's 3 altogether. So these first 2 properties are kind of like similar properties we learned with exponents. You know, when we talked about how multiplying or taking a product, so this is log of product, when we're multiplying 2 bases with exponents, what do we do with those exponents? You add them, right? We talked about this last week. Well, this is kind of like that. If you're taking the log of 2 things being multiplied, a product, you can break it up into 2 separate logs that are being added. And that's called log of a product. Okay? Similarly, when we were doing exponents last week, or maybe it was the week before, if we were dividing 2 bases with exponents, we would do what with those powers? Subtract them. Same thing here. If you're taking the log of a quotient, meaning you're dividing, you can break it up into 2 logs that are being subtracted. Okay? So multiplying means break it to addition. Dividing means break it up into subtraction. But what we're doing today is actually going from this form on the right to this form on the left. That's compressing, taking 2 logs and rewriting them as 1. Tomorrow we'll be going from this side to that side and practicing going the other direction. Your goal is to be so familiar with those properties you can recognize them at any time, whichever form it's given to you. So that's 2 things. Product, quotient, multiply means add, divide means subtract. Okay. The other property has to do with if you have a power involved. So this is saying if you have some log where the thing you're taking the log of has an exponent, you can take that exponent and bring it out front and write it there. And once it's out front, we no longer will call it an exponent, we're going to call it a coefficient. Because it's a constant out front being multiplied by the expression. An example might look like, if I had log base 3 of x to the 4th, I could rewrite it, and it's an equivalent expression. I could rewrite it by bringing the power out front as a coefficient and having this. Those are equal things. And I'm not going to review these identity logs. They're fun, but I'm not really going to use them much in the lesson. I'm not even sure why they're still there. They've been grandfathered in from some other age. Okay, all these steps I'm going to talk about as we are working. So let's go straight to this problem right here. How many logs do you see? 2. What's our goal with those 2 logs? To get them as 1, right? To get them as 1. Look at step 1 on the bottom left and read it to yourself with your eyeballs in your brain. Take a moment. Spend some time with it. Step 1. We're reading step 1 to ourselves. Which of these terms the left one or the right one can I do step 1 on? Place any coefficients as powers. The second thing, right? The second thing. What's the coefficient on that second term? 2. So when it says rewrite it as a power, this is your log of a power property. You take that coefficient and you put it as an exponent right here. Okay. So this is step 1, log of a power. And the reason we want to do that is so that we can use log of a product next. Because if you look at your log of a product formula, there's no coefficients in front of the log. So we have to get that coefficient out of the way. It's in the way. Read step 2 to yourself, please. Step 2, if your logs are added. Are our logs being added right now? Absolutely. Okay, so it says, if your logs are added, multiply the values following them. I will highlight what that means, what the values following them are. It's this one and this one. We're going to multiply those and write it as one single log. So this is step 2, log of a what? Which property am I using that says I can rewrite addition as multiplication? What's it called? Log of a product. Product meaning multiply. How many logs do I have now? 1. If I was solving an equation, which I'm not, I would be in an excellent position now to do lasso so that I could solve for x. But we don't have equations today. That comes in 2 more days. We're not done with step 2. Go back and look at step 2. If your logs are added, multiply the values following them. Check. We did that. What does it say afterwards? FOIL or distribute as appropriate. This isn't a FOIL, but this is a distributive property. Okay. But before I can distribute, what do I need to take care of? The squared, right? I have to do my order of operations, which says to do exponents first. So that means this. 3x quantity squared, or parentheses squared, means 3x times itself, which is 9x squared. And step 2 said to distribute also as necessary or appropriate. What does it say? It says appropriate. So now I can distribute that 9x squared. And there's something about this answer that's making me twitchy. What do you think it is? The way I've written it. No parentheses, that's right. Right now, the way I have it written, the log is only being applied to the 9x cubed. That 27x squared is like this whole other thing floating out to the side. It's not included with the log. In order to show I need the log of everything that comes after it, I need parentheses. And I will be particular about the parentheses because it means something different if you're including them or not including them. It's 2 different things. So you definitely need the parentheses. So that's your answer right there. Okay. Does anybody need the screen up before I change it? Okay. How many logs do you see? 2. is, let's figure out where and if step 1 applies. Step 1 is the step that told you to take care of any coefficients and turn them into powers. Do you see any coefficients here? It has a coefficient of 1, but we kind of don't care about that. So there is a coefficient of 1, but if we were following our power property, that would mean bringing it over here as an exponent of 1. But it doesn't really change anything. It's not significant, so you really don't have to go through that trouble. It's good to be able to recognize it, but it's not much help. So you don't have to worry about that in the future. Only if there's a non-1 right there, something that's not 1. So that doesn't apply, step 1. Step 2 is for when the logs are being added. Is that what we have here? No. Step 3 is for if the logs are being subtracted. Is that what we have here? Yes. So read step 3 to yourself, please, with your eyeballs in your brain. If your logs are subtracted, divide the values following them. So we definitely have subtraction of logs, which means we're definitely going to be dividing some stuff. Please remember that the base, nothing's happening to the base right now. It's just staying 3. I'm going to give myself some fat parentheses, a nice division bar, because I'm going to be dividing some stuff. My question for you, though, is how do you decide what goes in the numerator and what goes in the denominator? The first one goes in the top, and the second one goes in the bottom. Kind of like whatever order you're reading from left to right is how you're going to fill out your fraction from top to bottom. The 3x squared 5x goes here, and the lone x goes in the bottom. It really feels like we're done, but we're not done. The other part, we will. The other part of step 3 says, factor and cancel common factors if possible. We absolutely can factor. Which part of the fraction can't be factored? The bottom. What method do I need to factor the top? What's the name of the method when we just pull out what they have in common? GC. Yeah, greatest common factor. Okay, so what do they have in common on top, those two things? What's the biggest common factor? Do the 3 and 5 have anything in common? Just x, right? Are you saying it and I just can't hear you? Okay. You're very far away. You're very far. You have to speak from your diaphragm. We yell it out. Okay, what's going to cancel here? X. But I'm sorry, which x? Which x is canceling with the bottom one? The one outside the parentheses. Why can't the 3x be canceled? Let me show you some bad math. Are you ready? This is bad math. Because the 3x is being added to the 5. You cannot cancel things that are being added or subtracted. Just things being multiplied. Those are called factors. Factors are being multiplied. Terms are added or subtracted. So it's these x's that get canceled, leaving me log base 3 of 3x plus 5. This is making me anxious and twitchy. Why? No parentheses. Thank you. That was from your diaphragm. Okay. Log base 3 of 3x plus 5. Questions on that one? Try the last problem. All right, buckle in. I'm going to show you some bad math. You see this? Bad math, right? Those don't cancel because they're not being whatted. They're not being multiplied. They're being added or subtracted. You don't cancel stuff that's being added or subtracted. Only factors can be canceled. Factors are multiplied. Terms are added and subtracted. So your answer is just this. Yeah. And you're done. Would you like for your homework to be turned in today before you leave? No? Okay, we won't do it. But I will